messy. So you just want to take this part. So this is going to stay. Then we take the d, this part, the dx, the derivative of 3x over 4x plus 2.
Yeah.
Bring that to the side and just find the derivative.
So this would be.
So like you can take.
So to have like just 3 over 4. Is that what you're saying? For the derivative of that.
That's
Yeah.
just 3 over 4.
Yeah, 3 over 4 because you get.
Oh no! You don't. The quotient. Don't you have to use quotient? Oh, do you?
It says calculate the derivative.
Yeah. Okay. All right. So if it gave us a problem like this,
Yeah.
y equals 3x over 4x plus 2, right? And it said.
I got Carter.
Oh, sorry.
Pluto's coming through.
Pluto?
Pluto.
Why are you Pluto?
Because nobody's ever taking pictures of me until. Really?
Like me?
Oh yeah, that's right. Yeah. You get a good one or not?
I showed my mom, and she was like, "He looks like that."
Oh yeah. Why?
I don't know.
Did you good at math or something or what?
No, you do.
What? You didn't look at the picture?
I saw you like the video.
What video?
Actually.
Oh, his video?
No.
Oh, that was a video? You take videos on the phone?
Yes.
Oh, what a waste of time.
Yeah. So if this was a problem by itself,
Yeah.
take the derivative. How would you do that? Like, all right, forget about the whole thing for a second.
Forget about what you just said earlier. Is that what you're telling me?
Yeah. Or just forget that this is a big problem.
Okay.
So imagine we just had one problem saying find the derivative of this. How would you do
Let's
it?
put that in parentheses with a 5, right?
Well, yeah, but this is off to the side. Well, I'll show. All right, we'll start from the beginning. I'll show you how we did it. So this is the original problem. Y equals 3x over 4x plus 2. All of that to the 5th, right?
Yep.
So we have to take the derivative. To the derivative, you just take the derivative of the whole thing. So that's 5, this to the 4th. Like, you treat this like it's a variable, right?
Okay.
So you go 5 times this to the 4th. And then you take the derivative of the inside plus the derivative of the inside.
Like this floor.
That's a chain rule. That's just like, that's what we memorize, what chain rule is.
I can't really picture it, so you gotta have to write it down.
Oh, yeah, I'll show you. All right. Like what we're saying.
I would do steps, yeah.
So what if you have to teach on the 10th floor?
I would take steps.
If this
I
is,
would.
I'm gonna rewrite the problem in a
Every
second.
day.
Go
You take some
upstairs.
classes.
We have to add that into the
X
traveling.
Yep.
to the 5th.
Okay. Well,
What if it was like 300 floors?
Really, whenever you take the derivative.
What if you-
So that would be like 4x to the 5th. I mean, 5x to the 4th.
Right, but wait,
But-
slow down for a
That's
second.
Percy building.
Let's look.
I
So when we're
actually
taking the
like
derivative,
climbed
yeah,
the
you take.
Okay, so when I was
So
in
dy
university, I was the
over
elevator.
dx.
That
It's
was
gonna
supposed to
be
be
5x
I don't think your kids
to
want
the
to
fifth.
go all of
No,
those.
4th.
I mean, my bad,
Yeah,
to
no,
the
it's making
4th, to the
it
4th.
Yeah, yeah.
Okay.
But then
Alright,
you do
so
the
for
plus,
this, we're looking,
So we like the
for
plus,
volume of
the
the
d
kind of
of
like that.
x.
The d of
So
x.
what
But d of x over
as,
d of x just
volume
cancels.
equals
But
AQ?
Yeah.
that's how you
Okay,
take a
and then-
derivative of anything, right?
Mm-hmm.
It's but
Just some
since
like,
this part
yeah.
cancels
Yeah,
out,
that's
we
what we're
don't.
saying.
We just
What do you
ignore
wanna
it
call
when you have
Like
the
a side
derivative of
cube.
x.
Yeah.
I thought you said 8.
Yeah.
Right.
So
So
then you take
That's
the
what I
derivative, so
meant to
wouldn't it be?
then, so when we have
T
5,
Mm-hmm.
this is, imagine this is like a variable.
squared?
Yeah, yeah.
5 this, you take 5 this to the 4th
Yeah.
But then-
plus d of this.
Remember that you're
That's all
Wait.
chain rule.
with respect to t.
Oh,
This-
okay, so
The
that's
derivative of the inside.
This one.
Right.
Okay,
The
so
whole,
that's what I
the whole
thought
thing,
was
or just the
Yeah.
top or bottom?
Just the inside.
And you know d
Well, alright. Well, first.
When you're
I-
saying inside, you mean the top or bottom, or just like both?
the whole thing.
Okay, so that means I would have like 3/4.
No, well, let me see.
Because you cancel out the 2.
Sides.
Isn't that-
No, since it's a fraction, you have to use quotient rule.
squared equals D.
I'm not familiar with that yet.
Quotient rule is
You
when
got-
you take
We know you gotta figure out what
the derivative of the bottom
1 second.
times the top minus the derivative of the top times
Oh,
the
it says
bottom
It says when it's 50. When the length
all
of the edge is
over
50.
the bottom squared.
It says right there.
Okay, so
Oh, I thought you were.
So where do we-
That that's yeah, like so basically the main rules you just have to memorize the only thing you have to memorize are the rules, like product, quotient, power.
It's gonna be 2,500.
I mean, the sum you already know, sum and difference.
It's just
you know.
AQ.
So those are the 4 rules you have to remember, and you basically use those 4 rules to solve each of the problems. So, yeah, whenever you have to take a derivative, like this is, we're going back to the beginning. When you take the derivative of a fraction, you have to use quotient rule. I could pull it up to show you real quick.
We're looking for the motion.
Just write it out.
Yeah, I just want to make sure I'm doing
Now
it
take the
right.
derivative. I think that's b equals length 2. Now take the derivative of size with respect to t.
It,
Right.
yeah, it's